And so The Mentalist is one of the television shows that I enjoy watching. If you get a chance, take an opportunity and watch it. In The Mentalist, Patrick Jane is an ex-psychic who helps solve murders by doing something called reading people. In other words, he'll be able to tell certain characteristics of a person just by looking at them and associating them with other characteristics. Now, throughout the show, Patrick Jane makes no bones about the fact that he's not using anything magical. He's actually using something called conditional probability. And so, if I meet somebody I don't know, and they smoke, the fact that they smoke allows me to estimate with greater accuracy the probability that they cuss. And so conditional probability is the probability of one outcome given that I already know the other one has happened. And so if I know the person smokes, I can predict with much greater accuracy the probability that they cuss. And so in our example of smoking and cussing teenagers, if you'll recall, we said that 35% of all teenagers smoke and 75% of all teenagers cuss. And we know that this actually translates into about 65% cussing, 25% smoking, and 10% smoking and cussing, although not necessarily at the same time. And so if I'm trying to read somebody as Patrick Jane would do, I'd say, well, what's the probability that someone cusses, given that I already see the characteristic that they smoke, or perhaps smell it on their clothes? Now, the very fact that I know they smoke automatically changes my sample space, because I no longer have to consider this 65% of everybody that cusses alone. I'm only interested in this 10 out of 35 that smoke and cuss. The probability has changed. And so what I'm seeing is that 10 have this characteristic of both smoking and cussing, or 10 cuss out of my total sample space size of 35. Now keep in mind we're dealing with probabilities here, and so this is the same as 0.1 divided by 0.35. I symbolize the probability of cussing given that somebody smokes in this way. P, C, and then this line S. So this means the probability of somebody cusses given that I already know that they smoke. And in this case, it ends up being approximately 0.285, a 0.285 probability that they cuss, given that I already know they smoke. And so I can do this symbolically by saying the probability they cuss, given that they smoke, is equal to the intersection set of cussing and smoking, which in our case was 10, and that is divided by the probability of the person smoking, which was 0.35 or 35%. And so there's our formula for the probability of one condition given another.